Welcome to our cryptography session. Today we are gonna look at the one of the block. It's called the output feedback mode, or OFP. Okay. Now look at the requisite of OFP. Okay, the first one is called the initialization vector, or IV, which is just a random block of a bit or string. The IV just to provide the randomness to the encryption, so that to the same message we not have the same output after encryption with the same key. The next one is a XOR operation. The operation basically take to the two messages and compare them bit by bit. If both bits are equal, the output bit will be 0. Otherwise, the output bit will be 1. To visualize the operation, look at the example on the above. 0 1 0 0 and 1 1 0 1 give the output of the 0 1 0 0 1. The plain text here mean the message that is not encrypted, where the ciphertext here mean the encrypted message. Okay, now we gonna look at the key point of OFB. Okay, the IV is encrypted together with the same key. Then the output or the encrypted IV is born with the plain text block. To produce the ciphertext block, the encrypted IV or the output here will be brought forward as the IV of the second round. The process is repeated until the plain text block are transformed into the ciphertext. Now we look at some application of the DES encryption. Okay, example, we're gonna use 64-bit block size and 64-bit key. The IV in this case is also 64-bit block. The IV will be encrypted together with the same with the key to produce the 64-bit output, which is export with the first plaintext block P1 to get the first ciphertext block C1. Okay, the output produced 0 1 will be brought forward as the IV of the next round and encrypted again to produce the output 0 2, and the second output will be again brought with the second plaintext block P2, and we get our second ciphertext block C2. The operation then continue until the plaintext has been encrypted, which we can hear the denotants rounds, and based on the pattern since we can say that the IV used in the round N will be the output from the previous round of encryption. Therefore, the denoted as the N1. The IV also encrypted, and its output will be again be executed with the last plaintext block PN. By doing so, we get our last ciphertext block CN to obtain the full ciphertext. We simply collect and merge all ciphertext blocks. Now we got our ciphertext ready. Okay. For decryption. Okay, basically the part of the part for decryption part is exactly same with the encryption part, but we gonna use the reverse style. That's only different is that this time the output will be executed with the ciphertext blocks instead of the plain text block by doing so logically. Okay. Okay, now we gonna look about advantage of the OFB. Bit error in the transmission do not propagate. Disadvantage of OFB, more vulnerable to message string modification attack. Okay, that's all. Thank you.